Okay, so part 2 of 1.1, we are going to learn how to detect our isotopes. Okay, macam mana nak detect. So there's a device that we can use to know how many isotopes we have. It is called the mass spectrometer. So it is an instrument used to measure the precise masses and relative quantity of atoms and molecules. So it can determine relative atomic mass, relative molecular mass, types of isotopes, abundance and relative isotopic mass. Okay, ini QI. Structural formula of the compound in an unknown sample. So maksudnya awak akan ambil awak punya unknown sample atau like a small amount of sample, lepas tu awak letak kat dalam benda alah ni. Okay, that is your mass spectrometer. Awak boleh jumpa dekat research centers or chemical centers, I guess. Okay, so the data that will come out, that will be produced from the mass spectrometer is called mass spectrum. Okay, it looks like this, where you have abundance and mass to charge ratio. Okay, so why do we need to, bukan why do we need. So let's see how this mass spectrometer works. So what you're going to do is you're going to take a small amount of sample, then put it in your vaporization chamber. So dalam vaporization chamber ni, your sample can exist as solid, liquid or gas, and then it will go through the chamber, okay, and enter the ionization chamber. So this ionization chamber is when your sample is bombarded, maksudnya dia kena attack, kena macam laser with electrons. Okay, so that will break up your sample tadi into positively charged particles. Okay, so ini dia dah asing-asing. Lepas tu dia akan jadi positively charged particles in the acceleration chamber. So acceleration chamber akan macam laju, macam shoot your charged particles. Okay, and then it will go through this magnetic chamber. Okay, and it will be detected at the ion detector. Okay, so your ions tadi ni, your ions of the same mass to charge ratio, okay, will undergo the same amount of deflection. So the deflection ni yang ni lah. Okay, kalau dia size dia this particular size A, dia akan deflect begini. Kalau dia lebih berat atau ringan, dia lebih berat, dia akan deflect kat sini contohnya. Sini, okay? Macam tu. So maksudnya awak punya data untuk different mass to charge ratio will be different lah untuk each isotope. Okay, sebab isotope awak, dia punya mass to charge ratio akan berbeza lah for your isotopes. Alright, so then your data will be recorded and you will get your mass spectrum. Okay, so how does your mass spectrum look like? We need to know, we need to understand how to read your mass spectrum. Okay, so now we're going to interpret the mass spectrum of magnesium. So let's say okay, let's say pula, okay, if you look on the left here, this is your mass spectrum. Okay, on the x-axis you have the mass to charge ratio. Okay, mass to charge ratio. So this is actually the mass of your isotopes atau Mi. Okay, dia punya simbol yang kita akan guna, Mi. Okay, so awak ada magnesium 24, magnesium 25, magnesium 26. Okay, so here kita letak each of the mass. Okay, kita dah dapat dia punya data lah. Okay, so the height of each line is proportional to the abundance of each isotope. So abundance tu maksudnya berapa banyak awak punya isotope tu ada dalam sample of magnesium yang awak masukkan dalam mass spectrum tadi, mass spectrometer tadi. Okay, so awak masukkan 100% of your magnesium, let's say dia besar ni, okay, and then what happens? And then awak dah you find out that magnesium 24, okay, magnesium 24 dia ada 63. So 63%, okay. Let's say kalau awak campur ni semua, awak dapat 100% tau. So maksudnya ini actually 63% lah. So magnesium 24 you have 63%. Berapa banyak je daripada this 100%. Let's say dia banyak macam ni je. Okay, 63%. Okay. And then maksudnya magnesium 25 pula awak dapat berapa? You have 8.1%, lagi sikit. Okay, sangat sikit. Macam ni. So magnesium 26 you have 9.1%. Besar sikit lah. Macam tu. Okay. So maksudnya sekarang awak tahu, now you know that your isotopes are this much, okay? This much in like 100% in your sample of magnesium, okay? So from there, we know that magnesium 24 is the most abundant of the 3 isotopes. Magnesium 24 paling banyak yang awak boleh jumpa antara 3 isotop tu, okay? Alright, boleh? Okay, daripada awak punya mass spectrum ni, kita boleh kira something important daripada learning objective kita. Okay, this is important. We can calculate, tengok ni, saya tulis important. We can calculate the relative atomic mass daripada mass spectrum. So ini adalah simbol untuk relative atomic mass. Ini atomic, ini adalah relative atomic mass. Okay, so there are 2 steps, right? If you get a mass spectrum, first you have to calculate the average atomic mass. Okay, so average atomic mass, it is not the same as relative atomic mass. Okay, so average atomic mass, your value will have a unit, AMU, or also known as atomic mass unit. Okay, malas nak tulislah sendiri. Atomic mass unit. Okay, so to find average atomic mass, okay, we will use this formula. This is an important formula. Soalan nombor 1 dalam PSPM kemungkinan keluar, ya ke nombor 1 ke nombor 2, keluar soalan ni. Okay, manalah tahu kan. Okay, this formula, cara nak ingat dia, you can call it E-Kimi. E-Ki. Okay, senang je nak ingat. Okay, so E ni apa? It is the summation of, okay, the product of Q, relative abundance or percentage abundance of your isotope, okay, with the mass, mi, isotopic mass atau mass of isotope, okay, same thing. So for relative abundance or percentage abundance, you don't need to put any unit, okay, but for mass, your unit is AMU. Okay, so kat sini saya tunjuk yang awak punya MI tu, mi tu ada unit AMU. Okay, so bawah ni pula ialah summation of your relative abundance. Kalau macam tadi kan, yang ni 63, 8.1, 9.1. Untuk cari summation of QI, awak campur je lah. Campur 3 ni. Okay, awak akan dapat 100. Alright. Okay, so when we get the answer, okay, this value, it will have unit AMU. Okay, because of what? Because of this. So this is average atomic mass. Alright. So after we get the average atomic mass, we can find the relative atomic mass. Apa yang kita nak cari first ni. So relative atomic mass, or this symbol here of your element, okay, we will use this formula. Okay, mass of one atom of element in AMU. Where do we get this? If you notice, I highlighted this as purple and this one as purple as well. This is actually the same thing as this. So basically, you have to use this value, masukkan kat sini, okay? That's why dia punya value kat sini AMU. Boleh? Divided by 1/12 times mass of one atom of carbon-12. So, dalam formula ni, this bottom part, this denominator is actually fixed, okay? So, awak memang akan guna 1/12 kali dengan 12.00 AMU. Okay? So, ini adalah mass of one atom of carbon-12. Okay. So, for relative atomic mass ni, bila awak buat awak punya calculation, your kiraan, you will cancel out this 12 with this 12. Okay? And you will cancel out the units, AMU, from up here with this unit. Okay? So, your relative atomic mass will have value with no unit. Okay? Dia tak ada unit. Okay? Ingat, relative ni actually means dia ratio to something. Okay? In this case, carbon-12. So, dia akan, bila ratio kan, dia macam awak bandingkan dua benda with the same unit. So, awak akan cancel out awak punya units. So, that's why dia dimensionless. No unit. Okay, ingat relative maksudnya ratio, no unit. Kalau awak bagi jawapan ada unit, betul tak? Bila dia minta relative atomic mass? Salah lah, okay? So, ingat tu. Alright, first example. So, we have copper. Okay, Cu, it consists of two isotopes, which is 69% of copper 63 and 31% of copper 65. So, bila awak nampak percent ni, okay, it means that this is your relative abundance atau percentage abundance. Okay, blah blah blah. Okay, next, the isotopic mass of copper 63 and copper 65 are 62.9 AMU and 64.9 AMU. So that means this is actually your mass of isotope. So isotopic mass ni samalah dengan mass of isotope. Okay, same as this. So now we have this information, and then the first question asks us to define what is isotope. So, how do we define our isotope? Awak boleh refer balik kat depan, tengok balik explanation saya yang tadi tu. Use that definition, okay? Okay. Next, we're going to calculate the average atomic mass of copper. Okay, tengok sini. Dia kata average atomic mass of copper. So, awak punya average atomic mass of copper tu, average atomic mass, it will have unit AMU or not? It will have unit. Okay, it will be in AMU. Sebab dia tak ada cakap relative. Betul tak? So, simple je lah. Awak akan guna this formula. Okay, so kita dah ada this information. So, awak masukkan je lah. But if you are confused with this information, so I suggest you to draw out your mass spectrum kalau awak confused, okay? So, for copper 63 and copper 65, we know that it has 69% and 31% respectively. So, kita lukis lah, okay? So, ini copper 63, saya tulis ini. Dia punya percentage will be 69%. Let's say this is 69%. Okay? So, ini 69%. Next, we have copper 65 with 31%. Macam ni, kononnya. Okay? So, this is 31%. Right. So, sekarang kita dah ada QI. And then, we want the isotopic mass. So, kita nak guna mana? Nak guna ni ke? Nak guna 63 and 65 ke? Tak, okay? Since dia dah bagi tahu awak the exact isotopic mass, gunalah yang dia dah bagi tahu tu. So, for copper 63 it is 62.9 AMU. And then this one is 64.9 AMU. Okay? Alright. So, just follow this formula. Masukkan, divide, and then you will get this answer. Okay? Sorry. Okay. Example 2. For the mass spectrum of the element rubidium, what are the isotopes of rubidium? So, isotopes of rubidium. Cuba tengok dekat mass spectrum tu. So, you know that you have 2 here. Okay, 2. So, dia macam mana awak nak tulis? 85, rubidium 85 dengan rubidium 87. Okay. So, ini dia minta apa ni? Dia minta isotope notation lah. Okay. Next question, dia minta what is the percentage abundance of each isotope. So, percentage abundance, maksudnya macam ni kita nak kira tu. How? Is it that hard? So, it's not that hard. It is actually just maths, okay? So, to find percentage abundance, okay, awak tulis ni. Of each isotope, kita dah tahu. Tadi 85 dengan 87. So, for the first one, 85, rubidium 85. Cara kira ialah, ambil lah awak punya percentage yang atas ni. 18 over, total dia berapa? 18 campur dengan 7, okay? Kali dengan, since dia nak percentage, kali dengan 100%, okay? So, awak pun dapat jawapan dia. So, awak kira lah juga, sama untuk rubidium 87. Okay, same thing, just like kat sini, 7 over 18 plus 7 kali dengan 100%. Boleh? Okay, simple kan? Okay. Ni yang bawah ni, calculate the relative atomic mass of rubidium. Okay, relative atomic mass maksudnya A, R. So, since we have a mass spectrum, that means that we will be using 2 steps. So, first step, macam tadi, cari average atomic mass. Okay, guna formula ni. And then you will get your answer in AMU. Okay. And then second step, you use this formula. Okay. This value masuk sini. Okay. Ini akan cancel out with this. So this will cancel out with this. And then you will get your answer. Alright. No, you need. Okay, guys. Right. Next example, we will calculate the relative atomic mass of neon from the mass spectrum. So, ini pun benda sama. Okay. So, ini adalah jawapan dia. So, try doing this by yourself. Ni saya dah letak ni hint pula. Reminder yang this part here, it is fixed. Okay. Maksudnya, bila awak guna formula ni je, part bawah ni sama je. Ni awak kena ingat ni. Okay. Right, now let's say if you get this kind of question, dia bagi tahu awak the ratio of the relative abundance of naturally occurring chlorine isotopes begini. Okay, so what are you going to do? So, bila awak dapat macam ni, okay, this is relative abundance kan? So, awak guna je this value. Macam mana? Awak letak over 1. So, from here, you can already get your relative abundance lah, or QI. Okay, so just use this values directly. Okay. Next, it says based on the carbon-12 scale, the relative atomic mass of chlorine-35 is this and chlorine-37 is this. So, calculate the relative atomic mass of chlorine. Okay. So, dalam question ni, apa maksudnya based on the carbon-12 scale? It means that this one here, these two values, it is actually your isotopic mass. Betul lah. Isotopic mass or mass of isotope. Okay. But you don't need to divide with this value. Okay. You don't need to divide by this value sebab dia dah cakap this is based on carbon-12 scale. Okay. So, maksudnya awak tak payahlah divide yang ni. So, macam mana kita nak cari AR dia? You terus guna what formula? What formula, guys? You will use E mi E key. Okay. So, bila awak letak tu, masukkan je value awak. Okay, ni QI awak dah ada. Ni MI dah ada. You will get this answer. Okay. Relative atomic mass. So, tak ada unit. Right. I think this is the last example for 1.1. So, in this question, it says the relative atomic mass of lithium 6 and lithium 7 are 6.01 and 7.02. Okay. So, what is the percentage abundance, okay, of each isotope if the relative atomic mass, ER, is 6.94? Okay. So, daripada soalan ni, you have to know what information you can extract. So, this first line, dia kata relative atomic mass, okay, it is actually, for these isotopes, it is actually your mass of isotope. Okay. Since ini adalah isotope, ini adalah isotope kan. Dia bukannya cakap of lithium kan. Okay. Dia bukan cakap tu. Dia cakap of each of this isotope. Maksudnya ini adalah isotopic mass lah atau mass of isotope. Alright. So itu awak dah dapat MI. So next dia nak suruh awak cari percentage abundance. Percentage abundance maksudnya apa? Maksudnya apa? Maksudnya awak punya QI lah kan? Betul tak? Okay. Tapi dia tak bagi tahu benda tu, so awak kena cari with this information. Awak punya AR. Okay. So what we are going to do? We are going to assume. Okay. Bila awak dapat macam ni, awak akan assume that the percentage abundance of lithium 61 is, let's say, X%. Okay. So, maksudnya, the remaining, which is lithium 7, is 100% minus X. Okay. Ini adalah remaining dia lah. Okay. Alright. So, since we already know that AR, relative atomic mass of lithium, is 6.94. Okay, 6.94. That means you can put in your formula E key. Okay. From here, okay, kita masukkan our values ni. Kita punya QI kat sini. Okay, ni kita punya QI. Kita punya assumed QI. Right? So, masukkan. So, QI is X kali dengan 6.01. Mana dapat ni, Miss? Sini nak. Sini awak dapat. Okay. Plus 100 minus X times 7.02. Okay. Dapat dari sini. Atas ni. Over E key. So, summation of your QI tu. It will be X plus 100 minus X. Okay. Right. So kita tahu this equals to 6.94. So kita akan buat matematik lah. So bawa yang ni naik atas, kali, lepas tu ini pun kali, ini pun kali, ni kali. Okay, and then you will get your X. Okay, ini test awak punya mathematics skill lah, betul tak? Okay, so we find that X will be 7.92%. Okay, I hope you are doing this with me. Sebab kalau awak tengok je, awak tak faham tau. Awak tak boleh buat sendiri tau nanti. Awak tak ingat. Okay, kena practice. So now we have X. Boleh tak? So maksudnya kita tahu apa tu? Kita tahulah percentage abundance of siapa? Of siapa? Lithium 6. Okay. So this is 7.92%. So therefore the percentage abundance of this will be 7. Okay, lithium 7 pula is 100% minus 7.92 lah. 100 minus 7.92%. Berapa tu? It will be 92.08%. So sekarang kita pun dapat jawapan dia. Betul tak? So bolehlah bagi markah. Betul, betul. Okay? So that is how you calculate the percentage abundance when you are given the isotopic mass and relative atomic mass of your element. Okay? Alright, so that's all for 1.1. Good luck in doing your tutorials. I will put out the instructions of the questions that you have to complete. And yeah, if you have any problems, ask me, okay? Nanti kita akan discuss during tutorial time kita. Bye. Thank you.